Alright, so for the following examples, use like bases to solve exponentials. So here we see an example again where we don't have the same base yet, so we need to rewrite them. But it does look like I've got a 2, a 4, and a 2. So I think the only kind of rewrite that we need this time, right, is that 4 is going to be equal to 2 squared. So 2 to the 3n power times 1 over 2 squared is equal to 2 to the n plus 2. And then using our exponent rules, I can make this 2 squared actually a negative, right? So times 2 to the negative 2 is equal to 2n plus 2. And then I can, using my exponent product rule, if I multiply same bases, I add those exponents. So this is 2 raised to the 3n plus negative 2 equals 2 to the n plus 2. So I can rewrite that as 2 negative 3n minus 2 equals 2 to the n plus 2. So now since I have that one-to-one property again, same basis, I can just set those exponents equal to each other. So I've got 3n minus 2 is equal to n plus 2. Let's subtract our n's to the other side. So minus 4n minus 2 is equal to 2. Add 2, add 2. So negative 4n is equal to 4. Divide by negative 4, divide by negative 4, and ng equal to negative 1. And then like we've done before, we can still check this, right? So if I want to do my check here, so is 2 raised to the 3, negative 3 times negative 1 times 1/4, does that equal to 2 raised to the negative 1 plus 2? So 2 to the negative, positive 3. So is 2 to the positive 3 times 1 over 4 equal to 2 to the first power. And then if we rewrite this, right, that 4 there, that's actually going to be 2 times 2 to the negative 2, just like we did over here on our steps right here, right? So is that equal to 2 to the first power? And then using our product rule again, so this is going to be 2 to the 3 minus 2. Does it equal 2 to the first? So does 2 to the first equal 2 to the first? Yep, that checks out. So we've got a solution there that n is equal to 1. Negative 1 there. All right, so let's take one more example here. Same sort of idea, right? But ooh, we've got some bigger numbers. So 36, let's see. I don't think I can do 36 to some power to get me 216. So this is where we have to kind of think a little outside the box. I'm pretty sure though that 6 squared is 36. And I think, right, if we think about our exponent, 6 cubed is 216. So I can use 6's for this one. So I'm going to rewrite this first as 6 squared to the 3b divided by 6 squared to the 2b, and that's going to equal 6 cubed to the 2 minus b. All right, and then we can use our power rule. So an exponent raised to an exponent, we multiply. So in that numerator, I've got 6 to the 6b divided by 6 to the 4b. That's going to equal to 6 to the cubed, right? And 2 minus 6 is negative 4. So this is going to be 6 to the 6b over 6 to the 4b is equal to 6 to the negative 12. And then we can use our exponent rule, that quotient, right? So this is going to become 6 to the 6b minus 4b is equal to 6 to the negative 12. So 6 to the 2b is equal to 6 to the negative 12. We now have the same base, so I can set those exponents equal. So 2b equals negative 12, divided by 2, divided by 2, and b should equal to negative 6, right? And then we can check ourselves again, right? So we can do our check again. I think I'm going to use the kind of simplified version here, right, where we had this 6 to the 2b equals 6 to the negative 12, right? So we want to check this. So does 6, 2 minus 6, does that equal 6 to the 12? So 6 to the negative 12 does equal, right, 6 to the negative 12, so that checks out. So we see that our b value here is negative 6. So if the bases aren't the same, check and see how to make those bases the same, right?